Okay. I'm going to go through this in roughly this order of talking about the various Solaris security features that have came in roughly starting late Solaris 8 onwards through to Solaris 10. Mention some of the stuff that's still ongoing that hasn't integrated yet or has only just integrated into Open Solaris. I'm going to break it down into roughly 4 areas, talking about the minimization, least privilege, a little touch on virtualization, which is going to come up much more in some of the later talks today, touch on what we're doing in the area of crypto, and then a laundry list of one-liners just chucked on under miscellaneous. So this is what we often see as the big picture. We end up with all these individual features building up into a big architecture that can secure multiple services sitting on a single machine using many different parts of the individual features. I'm going to touch on bits of RBAC, bits of privilege, zones, auditing, everything as we go through this. And then you can take that and then layer across multiple different machines as well. So let's talk about services and minimization. So Solaris 10 introduced the most fundamental change to the way that Solaris starts up for many, many releases. Back in the SunOS 4.x days, we basically had 2 scripts, etcrc and etcrc.local. You wanted to add a new thing? Yeah, crafted it into the script in the right place. The whole thing was serial. No dependency problems because the dependencies were all sorted out by VI. And it worked pretty well. It was quick, it was well understood, but it didn't scale particularly well to lots of layered software. When we switched over to the Solaris 2.0 and beyond world, we moved on to System 5 init scripts, which did us pretty well for a long time. Dependency was based on ASCII sorting order, but it worked by and large. So why is SMF a security feature? Well, it allows us to do many things, very easily enable and disable services. If it ain't running, it's not going to be attacked as easily. It also allows us to delegate the administration of the service configuration and whether or not the services are enabled or not. And we can go extremely fine-grained on this, from you can enable and disable any services, but you can't change their policy, to you can change this one property of this one service. You can't restart it, you can't disable it. So, and it's all based on a single mechanism using authorizations. The authorizations came originally from our trusted Solaris product going back 14, 15 years now. And they came into Solaris in Solaris 8. SMF is probably the heaviest user of authorizations in Solaris at this point. So it allows us to do dependency resolution as well. Well, you wouldn't think that's a security feature, but it can be because it ensures that if you bring up the NFS service, the firewalls protecting it are up as well. And we now have IP filter in Open Solaris integrated into SMF as well, so that you can automatically, if you want to run it this way, when a service is enabled, a right set of IP filter rules automatically get applied, whether that's to open the service up or restrict it to certain networks as well. So nice tight integration there. We also used SMF to implement our secure by default. Secure by default, the idea was that the only thing that should be listening on the network remotely when the system came up after initial install was a secure way of remote access. And we chose SSH for that. Everything else is either disabled by default if it was installed at all, or it was changed so that it listened only locally. This was enabled in 2 different ways, either interactively during installation or jumpstart. And the other way was that we provided a command called net services. You could choose the open, the way we'd always done it before. If it was installed, it was probably running, or limited, which put you into this configuration of SSH and everything else local only. The default installation method was that for Open Solaris, we automatically went to the secure way. For Solaris 10, we didn't change things on upgrade, but you could opt in if you did a fresh install, or you could manually run the command. Something we should have done a long time ago, but it's there, very easy to use, because it's all based on SMF by and large. Starting mostly with towards the end of Solaris 8, but also Solaris 9 as well, we started to make our packaging system a bit more fine-grained with the idea of support and minimization. So the next best thing to it not being enabled is it's not even installed. There are various rules of thought about whether or not that's worth it or not, but a large school of people believe if you don't need Telnet D ever, just don't install it. It's an extra layer of protection on that particular system. Now the bad guy has to get the Telnet binary on there that happens to be vulnerable as well as get it enabled. So minimization, because of the way the packaging system works in Solaris 10 and before, can be complex. So there's a set of guidelines that URLs run off, and it says minimization support rules, and I think it's got .txt on the end. There's also a Solaris packaging companion that will help you work out the dependency relationships, because the existing packaging system in Solaris 10 is not particularly good in the installer, but actually be able to resolve the dependencies. All these problems go away when we move to the open Solaris world with the new packaging system. It properly understands dependencies, and the default is you start out with a very small amount on disk instead of let's install a whole DVD's worth of stuff, and you have to start picking what you don't want on it. We go the opposite way with open Solaris. Following on from the secure by default, it's minimized by default. The existing live CD, because it's graphical, is a bit bigger than many people would like, but when the text-based installer comes in really soon, the on-disk impact and initial install will be even smaller again. So, traditional Unix model, you're root, all-powerful, or you're just Joe Bloggs user. A little bit of a variation in between. There were some special groups for some things on some systems. It's basically too coarse-grained. Root's all too powerful. Users end up SU to root because it's the easy way to get everything done. For many years in Trusted Solaris, we had a different model, which was following the principle of least privilege, or that you only give the process the privilege it needs to do its operations. That was introduced in Solaris 10. The main difference between how we did this in Solaris 10 and how we'd always done it before in Trusted Solaris was we didn't break backwards compatibility when we did this. Set UID binaries to root still work. If applications call set UID inside them to flip around the user IDs, it all still works. If they want to be, they can be very finely privileged bracketed. Most privileges tend to be a one-to-one match to a system call. There are a few more complicated ones, like when you open a file, are you opening it for read or write? So there are more specific privileges around about that area. The idea is that some applications should only be using privilege when they know it's a user that's authorized, that's connected to them to do that job, and other times they shouldn't. Combining this with SMF actually allows us to take this least privilege model and apply it to services that we don't have the source code for or we don't wish to modify. For example, we haven't modified the Apache web server's core code to make it least privilege aware. There was a blueprint that myself and Glenn Brunette and some others wrote on how to actually privilege bracket Apache so that it runs with very little privilege all the time, not just starts up as root and drops a bunch of stuff. It never had this stuff at all. And it's all done just using SMF. There's a pointer to that blueprint off the sun.com blueprints page or off the Open Solaris security community. So how did we actually do it? Well, we took root, we broke it into, I think the first cut was about 45 or 48 different privileges. We're now up somewhere in the almost approaching 80 something. Basically, every time we introduce a new system call or a new privileged operation between user and kernel, chances are there's a new privilege coming in. So very fine-grained control. The kernel checks for privileges, not UIDs anymore. If you heavily privilege bracket the applications, it helps as another layer of defense in exploits. So there are two, possibly three different types of privileges. The privileges that are the things that used to map onto set UID root. You can override the file permissions on a file. You can bind onto a privileged port. Privileged ports in Unix traditionally are all those below 1024. You can reconfigure the networking system, change your priority to be the highest in the system, take up all the resources, that type of stuff. Different to what we had done in Trusted Solaris previous versions, we also introduced the concept of basic privileges. These are the basic rights that normal Unix processes have always had. Now we can take them away. Why would you want to do that? Well, if you've got a server process that's not supposed to be able to execute binsh, why allow it to execute? If its job is to sit there and serve out web pages or serve out whatever it is, it doesn't need to execute other programs. If it's doing so, chances are it's been exploited. Take away that basic right from it. Maybe even take away the basic right to create copies of itself, so fork. Chances are it has no business even looking at the output of PS, so take away proc info. It can't see other processes. Maybe it's not even supposed to be able to talk to processes that are running under the same UID if they weren't part of the same session. So take that away. So those were all there in Solaris time. And there's a project running just now to add some more basic privileges. First, for file operations, we have two new basic privileges, one called file read and one called file write. If you take that away, the process can't read or write any files. So really getting to the point where you're really sandboxing the process down. Then there's the special set called zone privileges. Zones, by their very nature, the way they're implemented in Solaris, they're a virtualization environment, but they're all running on top of the same kernel. So there are some operations on the system that would affect all the zones, and you don't want one zone to affect the operation of another. So there's a set of privileges that are by default not given out to zones, and a small, short list of privileges that we never allow to be given to zones because they would do too much damage to the system as a whole. Trusted extensions also has a bunch of additional privileges that aren't normally used on the system that are checked by the X server. And that's because we treat the X server as, although it's a user-land process, it's essentially part of the kernel when it comes to privilege. More on the trusted extensions and zone stuff in later presentations. So how does this actually work? Well, we actually have 4 different privilege sets. You have an effective set, it's what you're running with just now. The permitted set is the maximum that this process is allowed to get to. And you can, if you're a privilege-aware program, you can move privileges between the 2 sets. You also have the set of privileges that impact the child processes. There's the inheritable set, which is, it's like inheritance in English. It's the things you want to give on to your children, your grandchildren. Yeah. But, like in the real world, there's a tax. And that's the limit set. So, taxman wants his cut of the money and the things that you want to pass on to your children. We can effectively limit all subsequent child processes by changing the limit set. And that means that you can safely run programs out of server in type environments. You can run CGI bin scripts out of, say, Apache, because you can play with the limit set and ensure that even if they manage to find a set UID root binary, they can't take advantage of that because they're not supposed to. So you can both be good to your children and be mean to them. That's the same thing in a more set theory type notation. So how do we end up programming with the privileges? It's all with backwards compatibility. As I've said before, you can drop privileges, you can turn them on and off if you want to. There are a bunch of interfaces for doing it. For administrators wanting to use this stuff, it can be very difficult knowing when you can reduce the privileges of a program. There's a built-in program called ppriv that will list all the privileges with a localized description of what they're used for. It can also be used in a limited way to find out what you're missing or what you're using. And then there's a privilege debug Perl script that myself and Glenn Burnett wrote that matches a blueprint on privilege debugging. And that uses a combination of dtrace and privilege debugging so that you can help work out for the Apache service running in this zone to do this web service, exactly what privileges does it need. It's not completely automatic because you still need a human eye on whether or not these are the right things, but it's considerably easier than just running ppriv and blindly giving it everything. So moving up a little bit level from the privileges which impact the processes themselves, role-based access control first came into core Solaris, Solaris 8, again a trusted Solaris feature that's been around for a very long time. And the idea is to assign the privileged functions to specific user accounts. So get away from the model of there's the user world and then the admins all use root. Designate a real world role to a set of people that actually need to do it. The people that need to administer the printer system, they get a print role or a bunch of profiles that can deal with just doing that job function. People that look after the database get to just look after the database. And in an ideal world, there is no root password and nobody has it, or worst case is it's locked away in a safe and nobody uses it in day-to-day use. So RBAC is the mechanism in Solaris that we use to do that. And it brings together privileges, authorizations, and special accounts that we call roles. So first let's look at the authorizations, since we already mentioned they're used in SMF. They're just a unique string that represents a user's right. But there's a little bit of formatting to them. They're actually hierarchical, in that if you have solaris.admin, you automatically have all of those. If you have solaris.admin.printer, you have all three of those, but you wouldn't have the ability to administer networking. They're defined in either local files or they can be held in the name service. And if you're writing C-based applications, you can check them with checkAuthAtter, but there's also an auths command for people writing shell script that wants to check authorizations. By and large, authorizations tend to be checked by programs that are running with privilege, but not always. So we then have to have a nice, easy way of collecting together all these things that represent the real-world job functions and giving them out to the individual users. And the way we do that is a rights profile. It's a way of bundling together all the authorizations the users need, all the commands running with all the different privileges they need, and a nice, easy way to assign them to people. The rights profiles themselves are hierarchical. They can include other profiles, so that at the end of the day, hopefully you only assign one or two profiles to the real users or to the role accounts. So what's the difference between a user and a role? When we say role in Solaris, it's a Unix login account. It has a UID, it has a password, probably has a home directory. The only difference is it can't log in directly. And the way we enforce that is through PAM. So if you try and log in directly as the Oracle account, when the Oracle account's been created as a role, it'll say you can't do that. You have to first log in as a real user that's not a role, and then SU to that. When you're running with trusted extensions turned on, you can do the SU graphically, and you will get a whole GNOME workspace that will become running under that role. So this gives us a lot of accountability. We know what the real user was, rather than it was some random person that logged in as root or Oracle. Well, maybe they logged in on a local console, maybe they logged in over SSH. We don't know who the real user was. So part of the reason for this is accountability. It also means that if the passwords for these roles get disseminated a little bit too far, then it doesn't matter quite as much, because unless you're actually authorized to use it, it doesn't matter if you know the password. You can stick it in a sticky note next to the machine, but if Bob's not authorized to use it, but Alice is, he first has to subvert Alice's password, not just the role one. That's a duplicate. So privileges and the RBAC stuff, they complement each other very well. They fit together under the rights profile stuff. You can assign privileges, authorizations directly to users, but we recommend you don't do it that way. Most of the time, use existing rights profiles or define the rights profiles. Assigning them directly to users is going to lead to quite a complicated system. And in fact, you're not really assigning privileges to users, but to their initial login program. And it can be a little bit confusing, even though the admin tools allow you to do that. If there are any Solaris core pieces of functionality that you can't find a rights profile already existing for, we tend to regard that as a bug that should be fixed. We should be defining as many of these as we possibly can for you. So try and start with the ones we've already got, combine them together to get the job functions done you need. But root is still a little bit special, even having said all that. You've still got to have somebody in the file system to own all the files. And by and large, that it tends to be root. There are some configuration files that are often owned by an application-specific user. Or in many cases, what we've done is we've moved the configuration out of the file system completely into SMF. And the idea here is that if it's in SMF, we can control it with authorizations. We're no longer requiring you to be able to edit a file, which means you have to be able to get UID 0. You're back to square one. So where we can, we're moving the configuration either into SMF or closer into the application itself and trying to get away from editing a file with an editor as root. The idea being is that to modify root-owned objects, that could possibly result in privilege escalation. So if you don't have it, we're going to do the best we can to make sure you don't get it by other means. In addition to this, we also added a bunch of additional mount options to try and help with this as well. So you can much more easily say these file systems just cannot get set UID at all, which means they can't get any forced privilege. So which is preferred? Run as UID 0 and drop privileges, or run as a non-root user and add privileges? We tend to prefer the non-root UID and add privileges because it's more obvious and easier to understand and at less risk of privilege escalation. Both are fully supported and both work. Recommendation is to run as a non-root user with additional privileges. In most cases, there are cases where that doesn't work. So a little touch on the virtualization stuff now. Before I go on, there's any questions on the RBAC privileges stuff? Yep, far away.
Yeah, you said there were cases where it doesn't work to provide privileges rather than to drop privileges. Clearly, you have some examples of that.
It's not so much that it doesn't work, it's that there are some times where it's better to run as, say, the web server user and add net privadra, and always start out that way, rather than start as root and drop a bunch of privileges.
Right.
And it depends on whether or not you're modifying the code, whether you're writing it in SMF. And at the end of the day, the best test is, can the admin look at the system and feel comfortable? And it often makes them feel much more comfortable when they run PS and they don't see very many processes running as root, particularly because not all the admins that run PS might even be aware of privileges, and they say, oh, it's not a lot of stuff running as root. So a lot of it is warm, fuzzy feeling, rather than there's definite one way or the other. The cases where you've got to be concerned is, if you are running with UID 0, you can read files that are only readable by UID 0, for example, the shadow file. So that may be a case where, if all you need to do is be able to read some files, it's better to run as a non-root user with file.dac RAID. Or it really depends on the individual situations, but the general rule is non-root user and add privileges rather than root and take away.
Yeah, I got that part.
Yep.
What I was wondering is, you said that sometimes that doesn't work. Do you have specific examples where you have to start as root and then drop privileges because you can't do it if it works?
File access is one of them. The other is where you can't modify the code of the application, and in particular, a horrible example, but it's unfortunately real world, is a lot of services start out with a piece of shell script, and the shell script write temporary files in all sorts of places like var run. So you've got to start out as root to get that PID file in there that we don't really need in SMF, but we're not changing the code. So you've got to start out as root and get it to drop privileges. And that's why I say it depends. Depends on how much control you've got. If you've got time and can modify the source, in most cases you can probably get to a model where you were never root. But there are some cases where you've got to take the compromise because it's not worth the effort.
And if that's, I need an unprivileged user to be able to NFS now.
An unprivileged user.
Well, I have a non-root user to be able to NFS now.
Can we maybe talk about it afterwards? It seems it's probably going to get detailed too quickly. I don't want to get through all the slides. Yeah, one more before we.
You talked about adding profiles instead of privileges directly to the user.
Yep.
Now, one difference I see, if I have privileges directly to my user account, I can just do things without having to prefix my commands with profiles. So that is one nuisance benefit.
Right. So the one example where I find it's actually good to give the privilege directly to the user rather than giving them a profile that can run a command with that privilege is when you're giving out the dtrace privileges. If you're going to give somebody the ability to run dtrace against the kernel, chances are they've always got it. And you don't care whether it's an existing logstack command or some script they do themselves. One of the reasons I wouldn't recommend people sign things directly to users is because unless it's a single user or a very small number of users in the system, chances are there's lots of people that are going to change over time that are all going to have these job functions. So it's better to create a template. And the template is the rights profile, and assign the profile to the user. It also gives you the ability to more easily distribute it around the network and to change the underlying implementation over time. If you want to add more commands, change what things privileges run with. It's easier to change the implementation of the rights profile than have to go and visit every user account on every machine. So it's more of a management thing. The dtrace privileges tend to be the bit of a special one, and that's the one where I tend to break my own rule, and that's like, just give them dtrace kernel directly. Because if you trust them that much, yeah, it's okay that way. And it's more flexible for that particular use case. But by and large, I tend to prefer using rights profiles. And in some cases, rights profiles assigned to a user, some cases, rights profiles assigned to a role. It depends whether you have that need for the secondary authentication or not. Because the role, giving you that jump between I'm an ordinary user to I'm doing something with privilege, there's two different models. There's the, you always want that user to run it with privilege, or you want them to do it consciously. And how much conscious do you want to give them? Is it enough to type pfexec in front of it, or do you want them to actually re-authenticate? And if you want to re-authenticate, you use a role. So we give you the three different kind of points on that graph of how to do it. I think there was one more on this one before I move on to the next part.
Okay, I have a question here about this. There's also SE Linux. It does something very similar to Linux.
It doesn't really, but continue with your question, because it doesn't use privilege.
As far as the roles go, if you talk about the service mesh, I talk about the role stuff. And
So-
I know there's a lot of stuff you can rewrite for that. How hard would it be to rewrite that stuff for Solaris? That's my question. We've already rewritten patch.
You'd probably better answer this than me, Glenn.
Later about just extensions, but I'm not real clear if your question is this not working? Now it's on. Okay. So is your question how difficult would it be to add type enforcement? I'm not sure you didn't ask a very specific question.
Okay, what I'm saying is that there's a lot of stuff that's been rewritten for SE that started debate.
Well,
And how hard would it be to extend, to take that stuff into Solaris?
well, SE Linux is supposed to be transparent to applications, right? Applications aren't written specifically to run with SE Linux.
That's not exactly how it always works out.
So that's why I don't understand your question. Both of these architectures are supposed to be working smoothly with existing applications. So the question isn't clear, because if both SE Linux and Solaris work with existing applications, what's your question?
Maybe I'm not phrasing it right. Don't worry about it.
But the way that SE Linux uses the word role and the way we use it are very different.
Yeah.
And it's because they have a type enforcement, right? They have a type enforcement background.
I guess our role mechanism is based on Unix user IDs, and theirs is not. And also, their mechanism requires you to enable SE Linux to have a role mechanism, and our role mechanism is separate from our multi-level security mechanism. So our stuff is easier to use because it's at a different layer, and isn't so tightly tied up. All the features aren't all tied into the security context the way they are in SE Linux.
Okay, yeah, that's actually what I was asking, is if you have, if I have, how hard would it be to create equivalent profile in Solaris that you do on Linux, I guess?
Oh, you can create the same abstractions, but I think we'll make the point, it ought to become clear as we go through that what we do is a lot easier than what they do in SE Linux.
Well, I'm familiar with SE.
Okay.
Any other questions on this part before I move on? Ben?
So one of the primary advantages to using roles is using a profile shell, because typing pfexec all the time sucks. But there hasn't really been a lot of love for the profile shells.
Okay, so Casper is working on enhancements to the profile shell at the moment. So the first implementation of the way the profile shell works is, so the profile shell is just, it's K shell, C shell, whatever, that automatically sticks pfexec in front. Some of the, I think K shell and SH, but not CSH, had an implementation where it tried to cache some of that in its normal command caches to avoid some name service lookups. But So Casper's working on, at the moment, taking pfexec and making it a first-class citizen so that you don't have to modify the shells themselves. For the moment on Open Solaris, we have no profile K-shell because K-shell 93 didn't get modified. But the idea is that the profile shell will actually become an attribute that gets inherited down. So you will have not only profile shells, but you'll have profile VI and everything else as well. So making it the concept of first-class citizen so that you don't have to modify the shell code. We can have pfzsh, you can have restricted profile shells, stuff like that, without having to go back and modify the shells. So that's a work in progress just now. It's been ARC approved. I don't know how far along the actual implementation is. I know it was prototyped before it was ARC approved, so it's coming soon.
Has the case?
Case is approved.